Hello, 7th graders. I am creating this video to go through our paper copter scale factor examples. So we did start this last week Friday and went through design number 1. Some of my classes finished design number 1 and some did not. So I'm going to start from the beginning. Some of you, it might be a little bit of a refresher. And we're going to go through designs 1 through 4. And your homework is going to be to complete design number 5 by using all of the information we've learned about with scale factor. So the first thing that I want to draw your attention to is that we have our control group right here. So the control group, remember, is the paper copter that you have in your green science folders right now. That paper copter is our control copter, which means we are going to compare all of the changes that we make in our designs back to that control copter. That will allow us to know if the changes that we're making are helping us in terms of our paper copter hanging in the air for a longer amount of time, or if the changes have hurt us and it makes our paper copter drop faster. Remember, our goal in this lab, in this experimental design and engineering challenge, is to create a paper copter that hangs in the air the greatest amount of time. That is our goal. So without further ado, I'm going to jump into design number 1. So remember, last week we asked ourselves 2 questions right off the bat. We wanted to know with design 1 which thing was being altered, so what the independent variable was, and then if it was becoming bigger or smaller. So pause this video and I want you to ask yourself those 2 questions. So which feature is being changed? That also means what is the independent variable? And is that variable getting bigger or smaller? All right, hopefully you've been able to answer those 2 questions. So right away, I can see that our blades here have gotten smaller. So I'm going to write down that the blade length is the factor or the feature that's being changed, and then smaller. Now, I think last week, Friday, I did talk with each of my groups about, each of my classes about the number 1. Okay, so when we're talking about scale factor, remember we talked about how if the scale factor is bigger than 1, it means that the feature that we're talking about is getting larger. Okay, so bigger than 1 equals bigger feature, right? And if it's small, if the number is smaller than 1, and that means, remember, that means fraction or decimal, and that's going to mean that the feature is smaller. So remember that number 1 is really our cutoff. That's our boundary. So if it's bigger than 1, the scale factor number is bigger than 1, it's going to be a bigger feature. And if that number is smaller than 1, it's going to be a smaller feature. So now looking at our design number 1, we already said it's going to be a smaller feature, right? So then our scale factor should be less than 1. So let's keep that in mind. All right, so on our control group, we know that the blade length was 5 centimeters, and it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. And now I can look on my design number 1 and count our boxes. 1, 2, 3, 4, 5. So 5 boxes. And now I'm going to think to myself, 10 to 5. How am I going to get from 10 to 5? What am I going to multiply by to get from the number 10? So 10 times what equals 5? And this is really what I'm trying to answer. The answer here is 1/2, right? We answered this one last week Friday with most of my classes. So our scale factor equals 1/2. Remember, you can also write it as 0.5. And so now I'm going to take 5 centimeters, and now I need to figure out what this dimension is, right? So I'm going to go from here to here. What is this dimension then? 5 times 1/2 is 2.5 centimeters, okay? And I can also double check my work. Remember last week, I'm gonna go down here and we're gonna switch colors again. Let's go green maybe. Remember, we talked about how one box equals half of a centimeter, right? Or 1/2 of a centimeter, which means that 2 boxes is equal to 1 centimeter. We did that math together last week. So if I look back at this, I have 1, 2 boxes, that's 1 centimeter, 3, 4 boxes, that's 2 centimeters, and another box is 1/2, so 2.5 centimeters. All right, I hope design number 1 made sense. Let's talk about design number 2 now. So I'm gonna take this lovely little thing and move it over there. And we're gonna switch back to blue. So now we're talking about design number 2. Again, I want you in a moment to pause this video. And first of all, we're identifying the blade length, or I'm sorry, not the blade length. We're gonna identify which variable is changing, right? So what is our independent variable here for design number 2? And then I want you to identify, is it getting bigger or smaller? Okay, so let me correct myself there again. Identify what the independent variable is. Remember, that list is on the front board. We came up with a list of all of the independent variables that we could think of. So first of all, we're gonna identify what is our independent variable. And then second of all, I wanna know if the independent variable was getting bigger or smaller. So pause this video right now, have those conversations in your pods. What's the independent variable, and is it getting bigger or smaller? All right, I hope you were able to have some good conversations in your group. The design number 2, what is getting changed, the independent variable for design number 2, we can see that our blades got skinnier, right? They got narrower. So the blade width is now what we're talking about, not length now. Now we're talking about width, how wide or narrow they are. And we can see that they definitely got smaller, right? They got more narrow or narrower. Okay, so now I'm gonna jump back to my original over here because we need to be able to identify the scale factor, right? So I'm over here on my control, and we're gonna take a look at how wide they were in the control group. So we're really kind of identifying this distance, right? So how wide they were to start. And I can see that it's 1, 2, 3, 4 boxes, right? So if 2 boxes equals 1 centimeter, then 4 boxes should equal 2 centimeters. So before, in our control group, our blade width was 2 centimeters. Now I want to look at our new design and find out how wide our new blades are. So we know that they got smaller, but by how much? So here we go. This is the new blade width over here, right here. And I'm going to count the boxes, 1 box, 2 boxes. And I know from down here that 2 boxes equals 1 centimeter. Let me round off the M on centimeter there. So we went from 2 centimeters on our control group to 1 centimeter on our design number 2. So remember, scale factor, greater than 1 means bigger. Scale factor less, nope, that's the wrong way, less than 1. Should say greater than 1, means it's getting bigger. Scale factor less than 1 is going to mean it's getting smaller. So right now, turn and talk, is our scale factor going to be greater than 1, getting bigger, or less than 1, getting smaller? If you said it should be less than 1, you are correct, because we went from 2 centimeters over here to 1 centimeter over here. And we know that means it's getting smaller. So our scale factor should be less than 1. So again, we went from 2 to 1. So I'm going to have to ask myself the very same question. So 2 times what equals 1? 2 times what equals 1? If you said the scale factor was 1/2 again, or 0.5, depending on if you want to do decimals or fractions, you are absolutely correct. So it's the same scale factor. The scale factor equals 1/2 or 0.5. Only we weren't messing around with blade length anymore. We were messing around with our blade width, right? That's the difference between these two. Awesome. So if you said the scale factor was 1/2, which is smaller because our blades were getting narrower or smaller, you are absolutely correct. All right, let's jump into design number 3. Let's see if we can figure this one out together. So design number 3. So first things first, remember we want to identify what is changing between the control group and design number 3. So identify what the independent variable is. Remember, you can look up on the front board. I still have that brainstorm list from last Friday of each of the factors that we could change. So which factor did design number 3 change? And then again, is it getting larger or is it getting smaller? Because that's going to tell us about the scale factor. So pause this video, turn and talk. What is the independent variable and is it getting larger or smaller? Awesome. If you said that the body length was the independent variable, body length, you are absolutely correct, right? So we can see over here, we had a pretty long body, and then we have a pretty short body now. So if you said body length, and now if you said smaller, you are 100% correct. So our body length is what's changing, and it's getting smaller. Okay, now, here's a really important thing to consider. If you are going to change body length on your example, I want you to notice that they did not just change this part, they did not just change this part, and they did not just change this part. Notice the entire body length was decreased, okay? And they should all be decreased by the same scale factor. And we can test this to see if we are correct. So let's jump right on in, and we're gonna start, with this part right here where it says 2 centimeters. So we have 1, 2, 3, 4 boxes, which is 2 centimeters. And now over here, the same part on the side here, we went down to 2 boxes. And I know down here at the bottom, 2 boxes equals 1 centimeter, right? And we went down to 2 boxes. All right, so what is our scale factor? One more time here on the front side of this yellow paper. What is our scale factor? Well, we took the number 4 times what to get 2. 4 times what gets us to the number 2. If you said 1/2 or 0.5, again, same scale factor on all 3 designs, you are correct. But notice how that scale factor worked differently in each of these designs because we had a different independent variable each time. The scale factor was the same, 1/2 or 0.5, but we were changing different independent variables. Scale factor was the same, independent variable changed. All right, so let's check our work. So right here we had 4 boxes, we went down to 2 because our scale factor was equal to 1/2 or 0.5. Let's check our other ones. So here we had 5 centimeters or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. So if our scale factor was 1/2, we should go from 10 boxes, 10 times 1/2 or 10 divided by 2 should get us to 5, right? 1, 2, 3, 4, 5. There it is. We know 5 boxes is 2.5 centimeters too. And then last but not least, we have the same dimension. So 2 centimeters, which is 4 boxes. And we already did the math there. We should go down to 2 boxes, right? If we are correct. And we are. So they did use the scale factor of 1/2 or 0.5 in each of the body parts here. So we can see body part here, 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 body part here. Okay, so all 3 of those body parts were changed with the same scale factor of 1/2 or 0.5. All right, I hope that made sense so far. Now, I think what we're going to do, I'm going to scroll on down to design number 4. And I want us to keep in mind a couple of things, okay? This is going to be a little tricky because you're going to have to flip back and forth between design number 4 and your front side. And what I want us to do here is, again, I want you to identify the independent variable and then if it's getting larger or smaller. And I also want you to identify your independent variable and if it's getting larger or smaller, okay? I will give you a helpful piece of information down here at the bottom. Remember that 2 boxes equals 1 centimeter. And that means one box equals 0.5 centimeters, okay? I'm also gonna write my scale factor information over here on the sideline. So remember, if the scale factor is greater than 1, it means it's getting bigger. And remember, if your scale factor is less than 1, it means we're getting smaller, okay? So right now, I want you to pause the video. I want you to go flip back and forth between your control group and then this design number 4. And I want you to determine what the independent variable is. And I want you to determine if it's getting larger or smaller. And then I want you to tell me if the scale factor is going to be greater than 1 or less than 1. So pause the video and go answer those 3 questions right now with your pod. All right, I hope you were able to answer my 3 questions. So we can see, looking at this design compared to our original control design, that our blade length is the thing that's being changed, right? Blade length is being changed. And I can tell that it's getting larger, right? It's getting bigger. I should say bigger, because that's what we've been saying this whole time, bigger. And then my scale factor is going to be greater than 1, right? Because it's getting bigger. Right over here, we can see if it's getting bigger, scale factor is greater than 1. All right, so let's flip back to our original control group here. And I'll stick with blue. So remember, we had 5 centimeters was our length here, and it was 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes. So down here, I want to count. Let's see how many boxes we've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, we have 15 boxes here. So we went from 10 boxes to 15 boxes. So 10 times what equals 15. I'm going to leave that hang for just a minute, and I want to also calculate what our length in this dimension is, okay? So what is the length of this blade now? So if it's 15 boxes, remember 2 boxes equals 1 centimeter down here. So I have 1 centimeter, 2 centimeters, 3, 4, 5, 6, 7, and then a half. So 7.5 centimeters is the length of my new blade. All right, so again, I can also ask myself this question then. We went from 5 centimeters times what to get to 7.5 centimeters? So this is a little bit tricky, hopefully not too tricky for us. I think looking at this version might be a little bit easier. So we can kind of divide by 10 on each side to solve for this question mark. So we have 15 divided by 10. I've got some factors here. So this is a 3, and this goes down to a 1, right? Because 15 can be divided by 5 3 times. 10 can be divided by 5, 2 times. My mistake there. So our scale factor here is 3/2, if you like fractions, or if we take 15 divided by 10, I can go into my calculator and show you this. I don't have my calculator here. Let's see if I have one. Calculator. I don't have one. All right, let's see if it'll do it here. So 15 divided by 10 gives me right here in the center is my answer, 1.5. That's my scale factor, is 1.5. So 3/2 is also equal to 1.5, depending on if you want to go with decimals or if you want to go with fractions. So 3/2 or 1.5 as our decimal, that is the scale factor. And notice 3/2 is greater than 1. And 1.5 is also greater than 1. Our scale factor is greater than 1 because our blade length has increased. It's gotten bigger. All right, so the last thing that I'm going to have you guys do, and this is going to be your homework for tomorrow, is to draw a copter model. that changes the width of the, we're not going to call them rotors, we called them blades. You can make a change on yours. So draw a copter model that changes the width of the blades by a scale factor of 2 in the space below. So real quick, remember blade width is this. Let's go change this to that orangey color. Blade width is this dimension, okay? So this is what I'm asking you to increase, is the width of the blades. And our scale factor equals 2. I want you to turn and talk real quick. This should be a real fast one. If our scale factor is 2, does that mean the blades are getting wider or narrower? Turn and talk real fast. It means they're going to get bigger or wider, okay? And we know this because 2 is greater than 1. All right, so your homework in this space is to take our original copter. That's this one right here, our control group copter. And you are going to make these blades wider by a scale factor of 2. Okay, and you're going to do that in the space provided below. If you have any questions about this, please shoot me an email, talk to the sub in class. Otherwise, I hope to be back tomorrow and you can see me during win time. All right, that's all for our scale factor lesson.